Hello and welcome. Today we're doing another question from LeetCode 75, and this one is surprisingly simple as long as we understand what we're being asked. What are we being asked? Two strings are considered close if you can attain one from the other using the following operations. We have operation 1 where we can swap any two existing characters. So here we swap B and E, they just reposition themselves, and operation 2 we can transform every occurrence of one existing character into another existing character, and vice versa, right? So if we have 3 A's here and 2 B's, we just switch the A's and the B's, so now we have the 3 B's and then the 2 A's. We're switching the frequencies. And you can use the operations on either string as many times as necessary. Given two strings, word 1 and word 2, return true if word 1 and word 2 are close or false otherwise. So using those two operations, can we get one word from the other? Example 1, we have ABC and word 2 is BCA. So we can use operation 1 to basically just swap two characters, and we would be swapping B and C. So we go from ABC to ACB. And from ACB, we again swap one more time, the B and A, and we get BCA to finally get word 2 from word 1. And we didn't only have to use operation 1 here, we could have also used operation 2. We could have just switched the frequencies of B and A, and it would have done the same exact thing. Example 2, we have word 1 being A and word 2 being AA. Now we'll never be able to convert word 1 into word 2 or word 2 into word 1. The only two operations we have available to us are to swap existing characters, so reorder where they occur, or just switch the occurrences of characters. We can never add another character. So if they're not the same lengths, we'll never be able to transform one into the other. And example 3, we have CABBBA and ABBCCC. Can we convert one into the other? Yes, we can, and we're going to take a closer look at this example over here. So we have word 1 and word 2. The first thing we want to do is swap out the B and A. So this B becomes A and this A becomes B. Now from here, we just want to switch the frequencies of C and B. So this becomes CCC. And finally, we want to switch frequencies again from A to B. So we get A, B, B, and this becomes word 2. So we need to figure out if two strings are close, when is the only time that is going to be true. First, we know from example 2, they have to be the same length. If they're not the same length, we're immediately going to return false. So this is going to be our very first base case. Let's just write that out and get that out of the way. So if length of word 1 is not equal to the length of word 2, we return false. Now let's take a look at example 1 again. We just covered example 2 with the mismatched lengths. So example 1, we know we have the same exact length. We have ABC and BCA. But say instead of ABC, we had DBC. We'll never be able to convert one word into the other because the characters aren't equal. No matter how many times we reorder them or swap their frequencies, we'll never be able to produce an entirely new character. So first, we need our lengths to be equal. We also want the same exact characters. So both words need to have the same exact characters that we're working with. So now say we're back to ABC and BCA, except word 1 now has AABC and word 2 has BCBCA. So right now they have the same exact lengths, they both have a length of 5, and they have the same exact characters, right? They're only working with A, B, and C. The only problem is here the frequencies aren't the same. Word 1, we have 3 A's, we have 1 B, and we have 1 C. And for word 2, we have 1 A, we have 2 B's, and we have 2 C's. Now these frequencies don't match. If they did, even if they were associated for a different character, say word 2 was 3 B's, 1 A, and 1 C, we could just switch the frequencies around and have them equal each other with operation 2, but we can't do that since these frequencies are all different. So our third criteria is having the same exact frequencies. So we're going to need the same lengths, the same characters, and the same frequencies for whatever characters we're working with. If all of these are true, then we can always convert word 1 into word 2 using our two operations. So let's go ahead and code this up. We already took care of our first criteria of lengths. Now we need to check our characters. So for this, what we're going to do is make a dictionary for both word 1 and word 2. The keys are going to be the characters, and the values are going to be the number of times we've seen them. This is just going to be a counter for all the characters in our words. So for that, instead of writing out a whole dictionary, we can just use a counter. So from collections, import counter. All a counter does is it makes a dictionary for us. We can write that out or we can just use a counter. So we're going to have counts1 be a counter for word 1. And we're going to have counts2 be a counter for word 2. Word 2. So counts 1 and counts 2, this would look like the following if we had word 1 and word 2. It's just the same exact counts in a dictionary form. We have A being 3, B being 1, C being 1, and then A being 1, B being 2, C being 2. So now that we have our dictionary, we want to make sure we're using the same exact characters. So we want to see if the keys of our dictionaries of our two counts 1 and counts 2 are equal. This means we're working with the same exact keys and we have the same exact characters. If that's not the case, then we would return false. So we need counts 1 of keys equaling counts 2 of keys. So this is checking if we have the same characters, and we also want to make sure our frequency list is the exact same. So in order to get these frequencies over here, we're going to get the values of our dictionary and just sort them. Once they're sorted, we're just going to compare both of our lists to make sure they are the same exact list. We have the same counts for whatever characters that we've seen. So we're going to need both of these things to be true. We're going to need all these characters to be true and the frequencies. So counts 1.values. This is getting the actual values 3, 1, 1 in a list, and we want to go ahead and sort this list. So it's going to be sorted on this list, and we want to make sure this equals sorted of counts 2.values. And this takes care of that last requirement we had with the frequencies. So to recap what we're doing, the first thing we're doing is checking the length of word 1 and word 2. Both words have to be equal in length. Then we're going ahead and making two dictionaries where the characters are the keys and the number of times we've seen each character are the corresponding values. And we do this for both word 1 and word 2. Then we check if the keys are equal for both dictionaries, if we're working with the same exact characters. If that is true, and the values once sorted are equal, which means we have the same exact frequencies in both dictionaries, doesn't matter what character it's for, we're going to output true. But if either is false, we output false. So let's go ahead and submit this. And it is accepted. Now talking about space and time complexity, for time, we first go through every single character and add that to our dictionary. So that's going to be O of n. And then we also sort on the values that we have. So that's going to be an n log n operation. So our time complexity is going to be n log n. And for space, this is going to be an O of n solution if we have n characters in both words. Technically, we could argue this is going to be O of 1 because we know we're only ever going to have 26 characters. So we only need 26 keys in our dictionary. So this is actually constant, not dependent on how big word 1 or word 2 gets. But both explanations would work. So we just went ahead and solved determine if two strings are close. This is from LeetCode 75, and I have that whole playlist linked down below if you do want to check out other questions. But if you have any questions for this or comments, let me know down below. If this video was helpful, like, comment, share, and subscribe. It really supports the channel. And as always, I will see you in the next one.